should have your lab sheet up that looks something like this. We're going to work through it together in this lab. So make sure you have taken a screenshot of this, place it in freeform, and that you're ready to complete it as we work through the lab. The first thing that we're going to examine is how the height of this board that we have here is going to affect the speed of this car, which is really kinetic energy. So to give you an overview of the experiment, we're going to be adding additional books under the edge of this ramp. And we're going to see, as we increase the height of the ramp, how that affects the speed of the car. Now, the term we're going to be using is kinetic energy. Kinetic energy is simply movement energy, which you would have already picked up if you watched the background information in the pre-lab notes. So we're going to think about how does the height of the starting point here affect the kinetic energy of the car. And of course, as we raise the book stack and increase the height of the ramp, we're raising the potential energy. The potential energy is just energy before it turns into motion energy or before it turns into kinetic energy, because not all kinetic energy is motion energy. But that's the first question on your sheet that you can answer. And it's your hypothesis. If the height from which a car rolls increases, in other words, if you raise the ramp up, and as we raise the ramp up, the kinetic energy of that object will. So you can respond, if you keep raising the ramp up, as you raise the ramp up, will the kinetic energy of that object increase or will it decrease? So as the ramp goes higher, will the car go faster? Will it have more kinetic energy? Will the kinetic energy increase? Or as we raise the ramp up, will the car slow down and the kinetic energy decrease? So write your response for the first line on your sheet right here. The second line says, if the mass of the car increases. So later, we're going to run the same experiment, but we're going to add some clay to the top of the car here to increase its mass. So remember, mass is the amount of matter in an object. So if we add additional mass to this object, how will that affect the kinetic energy of the car? Same ramp, but if we add more mass, will the kinetic energy of the car rolling down increase? Will the car go faster? So if it has more mass, will the car go faster? Will the kinetic energy increase? Or will the car go slower and the kinetic energy decrease? Write down what you think on the next line for the hypothesis right below the one that we just did. The materials for this experiment that we'll be using are this small car I have here, a meter long board. This is actually a little longer than a meter, but that's the board we're going to use. A ruler, which I have here, and we're going to be using the metric side of the ruler. So you've probably done this in math class, but if you take a look, we're talking centimeters here and meters, because we're going to measure that too, not inches. Okay, so you want the one with the small lines, the centimeter side. 4 textbooks, and that's an important note. If your sheet for some reason says that we're using 3 textbooks, we're actually going to use 4, which we'll adjust soon. And then a meter stick, which is already laid out here. So everything we have is good to go here. And one other thing, if you haven't already done it, for the number of books, I know on your sheet it might say 1, 2, and 3. Change it so the number of books are 2, 3, and 4, both for the yellow box and for the green box down below. So change the number of books from 1, 2, and 3 to 2, 3, and 4. So our first step here is in the procedure. With the members in your group, find a place on the floor that will serve as your workspace. Your teacher will tell you where to work. We already have that done here. Step 2, place the board on the floor and put a book under one end of the board. So I have 4 here because I was showing you. And like I said before, we're going to change that to 2 books to get started. So we're just going to start with 2 books there. Step number 3 says, lay a meter stick on the floor nearby the end of the board. There we go. Beside the path the car will take after it is rolled down the board. So we have that set. And now we're going to do step 4, which is to measure and record the height from the floor to the top of the board. So it's really the top of our countertop here. I'm going to use the metric side, and from the bottom of the countertop, the top of the countertop to the top of our board, that is 10.5 centimeters. So go ahead and write that down for the height of the board, 10.5 centimeters. Our next step says, hold the car so that the back wheels are at the top edge of the board. Let the car go, but do not push it. So I'll go ahead and take our car here. I'm going to put it on the edge of the board and let's see what happens. All right, that's what we got there. And it went a total of about 20 centimeters. So we'll write that down for the distance travel. And our next step says, measure and record the distance the car travels along the floor, which we just did, from the lower edge of the board in the unweighted vehicle table. So, and by the way, we put that in the yellow table up here, okay, because that's the unweighted vehicle table. Also record the speed of the car as slow, medium, or fast, okay? That one, we'd say, probably went slow. So you can just circle slow, because it should have S, M, and F. And also, or finally, add a weight to the same vehicle. Okay. So we're going to do that later. We're going to skip that step. We'll come back to that and run everything through in just a minute. But let's repeat the step, but we're only going to increase the number of books this time, okay? So I'm going to add an additional book over here. So now we're going to see how the car acts when we have 3 books. Raising our ramp up, and let's measure the height again. I almost skipped a step here. So in centimeters, that comes out to be 14 centimeters. So let's write that down for our height. And now we can roll the car, starting the back wheels at the edge, and see what happens. All right, that one went, we had a little bit of a spill there, but that one went almost 45 centimeters. So we'll go ahead and round up, record that in your chart. And this is all in that yellow unweighted chart if you're not recording there. And this one, let's say that one went about medium. I'm anticipating that the next one will go even faster. Okay. Now we're going to add the final book to our stack here. And now we have our 4 book high stack. We're going to record that height. The height is 17.5 centimeters. So I'll write that down. You should write that down too. And now let's see what happens when we roll the car from that height. And that one exceeded the length of our metric stick. So we're going to write 100, since there's 100 centimeters in a meter, but we're going to say 100 centimeters plus because it went beyond that. And this one went fast. Now, according to our steps here, we're going to do the same thing, but we're going to add the weight to it. So we're going to put this putty on top, or not putty, we're going to put this clay on top, and we're going to run the same steps again, the same process over. Now let's get our table ready. This time we're going to be doing it in the green table. So on my little chart here, I'm going to erase the distance and the speed. And what you should do right now is in your green table, for the weighted tab, again, make sure you have 2, 3, and 4 for the books. But right here for the heights, we already know the heights of the books. There's no need to do that again because we already measured. So for your heights in the green table, you want to record for 2 books, 10.5 centimeters, for 3 books, 14 centimeters, and for 4 books, 17.5 centimeters. Since we already measured, we don't need to do that again. And I'm a big fan of not doing unnecessary work, but using our brains. So we've already measured. Let's put the clay on, and we're going to see how each of these heights affects the kinetic energy of the car. So we'll start here this time with 2 books and with our clay on top of the car. I'm shape it a little bit. All right, ready? All right, kind of a slow start, but that one went to about 33.5 centimeters. So that's the distance traveled for 2 books. You can already be seeing and comparing, oh, how does this one do compared to the other one that we just did? Now I'm going to go back and we're going to move it up to 14 centimeters with 3 books. And we're going to see how that affects the car, since we already measured that. Let that one go. Wow, that one went all the way beyond the centimeters. So you can see that's a big difference. Oh, by the way, I forgot to record the speed for the last one. So the last one was slow. This one was probably medium fast, but you can see the big difference here was how far it went. It went 100 centimeters plus already, which exceeded where the other one went without the extra mass. Now we're going to add the one extra book for the end here. Now we're up to 4 books, and let's see what happens as we do that. So let this thing go and see what happens. All right. Now sometimes it'll wipe out like that, so I'm going to do a couple other tests to see if we can get it to work. No telling what it's going to do. It may not work. It's got so much kinetic energy now, it gets out of control. All right, so we're just going to stop there because it keeps wrecking because it has so much kinetic energy. So we're going to say this one went to 31, but again, keeping in mind that it wrecked because it just couldn't keep going, but it was definitely fast, and it was moving along there. So if it would have stayed on its wheels, it would have gone beyond the meter stick to the wall for sure. Okay, so now that we have that done, we're going to come down to the bottom and answer a couple questions. How did the height of the starting point affect the distance and speed the cars traveled on the floor? So to put it in another way, as we raise the board up, and this is going back to our hypothesis, were we right? Were you right? As we raised the board up, did the kinetic energy increase? And did the car go faster? Or did it decrease, the kinetic energy decrease, and the car go slower? And also, think about how far it went. This is, by the way, just for the regular car. Did the car go a shorter distance when the board was raised up, or did it go further? So you're going to write what happened with the speed of the car and the distance as we raise the board up. So take a minute to write that down for the first question, the one that's right here by the green box. And if you haven't yet, make sure that you filled in all of both boxes. Now, our second question here is, how did the weight of the mass of the car affect the distance and speed the cars traveled? But thinking about what we just did, as we put this extra clay onto the car, how did that affect the car? Did the car go faster and further, or slower and not as far, or some other combination of those things? Write what happened on the line below when we added the extra mass to the car with the clay. Please make sure you use a capital and a punctuation mark at the end and that you have a complete sentence. Now, the last thing we're going to do is complete the graph on the next page, which for me is on the other side, but for you, you can scroll down and work on this. I'm on the second page of the lab where we're going to do some graphing. You can see that I have both tables here in the upper right, the yellow one where we had the car unweighted and the green where it was weighted. We are not going to use the green, rather we're going to we're going to graph the distance that the car traveled when it was unweighted. This is fairly simple to do. We're going to graph the distance traveled in centimeters, and we can do that by using the rectangle shape. So if you come up here to shapes, you can grab a shape, pull it down to the books, and then slide it over so it's a little bit bigger. And then we're just going to raise the top circle on the rectangle so that it reaches how far it went at first. So I'm totally making this up, but if I say for 2 books that have traveled about 5 centimeters, I'd leave that one there. And then I'm going to copy this. So I'm going to duplicate here, and there should be a plus button for you on your iPad where you can just duplicate. I'm going to move it over to the 3 books, and then I'm going to just show how far it went for 3 books. Again, this is going to be different for you, so you record what it is, whatever we recorded in our lab. I'm just showing you how you would do this. Don't copy exactly what I'm doing. You want to use what's shown in the table here. So you would look, for example, where it says distance traveled for number 2. That's where you're going to go. Distance traveled here. That's going to be your first one for 2 books down here. For distance traveled for 3 books, that's the number that you're going to represent with the bar graph here. And then you're going to do the same thing using the distance traveled for 4 books, and you're going to put that in the 4 books section right over there. So just make sure that you are replicating those numbers. I'm just showing you how this would work. I'll duplicate another bar, and then I'll move it over here. And then I'm just going to raise it so it shows the distance it traveled. And again, I'm making this up, so you should do your own graph when you graph it on the back. And you can also change the colors if you click on it to show the difference here so that it stands out. And there, you will have graphed it and shown how far it's gone. One other touch that you can do is you can write the exact distance here so it's really clear. So I'm going to write with these made up numbers. Of course, you want to do your own. I'm going to write how far they went so it's really clear because it's a little bit unclear. Making sure that I include my unit. And then up here, I'll write how far that went so that's really clear. And again, I'm making these up. You want to use the measurements that we recorded in the distance traveled.